Understanding chemical formulas and equations is like being able to read a code. And as we go through this and break this code apart, you guys are going to realize that this is a lot more easier and simpler than this all looks. Okay, you're going to realize this isn't as complicated as it seems. But in order to break the code, we need to find out what the foundation for this code is. What do all these letters represent? Where do they come from? Well, most of you that have been in a science room, I'm sure you've seen this, the periodic table of elements. Okay, this is kind of the foundation for the code. This is like the alphabet that we start our chemical equations off of. We base our chemical equations off of these. These are all the elements that we know of that exist in the universe. So if we start off with the letters, right? Well, where do we get our letters from? Once again, we get them from the periodic table. So when you see this H, where are we getting that H from? Well, it's up here. And what does H stand for? It stands for hydrogen. So that H, whenever you see an H, capital H, you know you're talking about hydrogen. Now, what about this one? We got an H and a little E. Well, what element is that? Is that one element or is that two elements? Well, this is an important feature. Whenever you see a capital letter and a lowercase letter next to it, that is all one element. In this case, this is the element helium. Okay? Now, they can't have two elements with the letter H, so they decided to add the extra E for helium so we can differentiate between helium and hydrogen. Okay? Now, we're coming up with another situation here. We have big capital letter C, capital letter O, capital letter C, and lowercase o. So what's going on in this situation? Well, remember what I just said. Whenever you have a capital letter and a lowercase letter next to it, that's referring to one element. In this case, C little o is cobalt, the element cobalt. What happens if we have a capital next to another capital letter? Well, that means this must be an element, and this must be an element also. So in this case, we have carbon and oxygen, two elements that are bonded together. Okay, so understanding what the letters represent, where you get them from, the periodic table, and to differentiate between capital and what the lowercase letters represent, that's also an important feature. So we've talked about the letters. Now let's look at the subscripts. Okay, so the subscripts are going to be these little numbers here at the bottom. Okay, now what do those numbers represent? Well, subscripts tell you how many of one particular element there is in a molecule. Now remember, this is important. A molecule is two or more atoms bonded together. So if you remember from the previous item we talked about, every capital letter, okay, represents an element. Okay, so in this case we have the element hydrogen. But this 2 right there tells us that there's 2 of these hydrogens. Okay, so in other words, it would look a little something like this. You have a hydrogen bonded to another hydrogen. When I say bond, I essentially mean that they're kind of like stuck together. They're attached to each other. So kind of like these magnets down here, you know, you got all these different little colors. Each different color can be considered an element, and they're bonded to each other. They're kind of stuck to each other. Okay. Now, what situation do we have here? We have the element carbon and the element oxygen, and there's a little 2 next to the oxygen. Okay, so we know that that subscript tells us how many oxygens are in this molecule. There's 2 of them. But what about carbon? There's no number there. Well, if you don't see a number next to that element, you can automatically assume that it's just 1. There's 1 element of carbon in there. So if we were to look at the way the molecule looks, here's your 1 carbon. Right? You have your 1 carbon right here, and then you have your 2 oxygens right here. So remember, the subscripts, these numbers on the bottom, sub means kind of bottom, that number tells you how much of each of these elements you have. 2 oxygens, 1 carbon, 2 hydrogens. Okay, now without confusing you too much, coefficients are going to be the large numbers that go to the left of an element or molecule, and they tell you how much of an element or molecule you have. And we're going to see right now how to distinguish between these two. So let's take the iron, for example. So I have 3 irons, Now notice this 3 is not in this space right here. If it was a 3 right here, if I had a number 3 right here, that would tell me that there's 3 ions that are bonded to each other, that are attached to each other, making a molecule. And that's not the case. If you look at all the ions here, notice that they're not attached to each other. It's 3 separate iron elements. They just happen to be floating around. There's 3 irons in there. Okay, just kind of floating around, not attached to each other technically, not forming a bond. Okay, now let's look at this example right here. We have CO2, just like from the previous example. We have 1 carbon. Here's your 1 carbon. And we have 2 oxygens, and they're bonded to each other, correct? All of these are attached to each other. They're all stuck to each other. But is this molecule here, is this whole molecule attached to this one? And the answer is no. These 2 molecules are actually separate from each other. These are attached to each other. These elements are attached to each other. So here's another CO2, but they aren't attached. Each molecule isn't attached respectively to each other right there. Okay, there's no bond there. So because of that, we say we have 2 CO2s. Here's 1 CO2 right here. Here's a separate CO2. So these coefficients kind of tell you how much of each element or molecule we have in there that aren't bonded to each other. Okay, now the last one are the parentheses. And once again, this isn't as complicated as it seems. Let's kind of break it down. So we have capital A, little l. So that means we have an element, right? Big letter, little letter, they're together, that's one element. Okay? We have a big letter here, big letter N, big letter O. So we have 3 different elements present: aluminum, nitrogen, and oxygen. Okay. Now, notice that the aluminum is outside of the parentheses. Now what that means is you're going to see right now that this aluminum is bonded to this nitrate right here. Okay? And inside this parentheses, which is what we're focusing on right now, okay, this nitrogen is bonded to this oxygen right here. Okay? Now, let's look at the subscripts. There's no subscript for aluminum, right? So we assume that it has a 1 subscript. There's going to be 1 aluminum in there. In this parentheses right here, the nitrogen has no subscript, so we assume that there's 1 nitrogen. And the oxygen has 3, a subscript 3. So there's going to be 3 oxygens bonded to this nitrogen. Okay? Now notice there's another subscript out here. So we close the parentheses, there's another subscript. Now this last subscript outside of the parentheses, okay, that tells us that there's 3 of these molecules. There's 3 NO3s. Okay? Now to help you visualize that, look what we have here. Okay? We have our 1 aluminum, right? Here it is. And then we have our nitrate group. That's this one. Here's the N. There's 1 N. And there's 3 O's, right? 1, 2, 3 O's. And how many of these nitrate groups are there? How many of these groups are there? Okay, well, there's 1, 2, 3. So that's where this 3 comes from. This, I understand, might seem a little more complicated, but once again, just take it step by step, break it down, and it'll make sense. It's not that bad, okay? For right now, we don't have to worry too much about these bonds, right? I mean, these pluses and minuses, we'll get into that a little later, but just understand how to break down a basic chemical formula, and you're going to see that these don't look as crazy or as scary as they used to just a little while ago, okay? We just break them down, letters, subscripts, coefficients, and occasionally parentheses, and you'll be fine.